assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
All right, so here we have a question about ionization energy. Anytime you have a specific term in chemistry, it's important to know what that term means before you start working the question. So when we're talking about ionization energy, it's defined as the energy required to remove an electron from a neutral atom. So we're talking about trying to reach in and take away electrons from an atom, all right? And so typically on these questions, you'll be asked to compare 3 different atoms, or 2, sometimes maybe more. But here we have kind of the standard 3-atom comparison. The atoms they give us this time are calcium, krypton, and aluminum. For these problems, it's important that you have your periodic table nearby, because what we'll need to do is take a look at where the atoms are on the table, because that gives us a clue as to where their electrons are. So what we'll do is for each of the atoms, we're going to draw out kind of the orbital diagram for their electrons. That way we can see which electrons we'll be losing once we try to start taking them away. So if we look at calcium, I'll kind of draw just the row prior to calcium and then the row that it's on. So calcium would have 3s and then 3p, and then it happens to be on the 4th row in the second group there. So I'll kind of fill in my electrons. For krypton, it is on the 4th row all the way at the end there. So it should give us plenty of electrons to work with. So it'd have 4s2, 3d10, 6, 7, 8, 9, 10. And then it'll finally have a full layer of 4p6. All right. And then finally, let's do the same thing for aluminum. So I'm going to reach back and kind of do the previous row since aluminum isn't since aluminum isn't all the way at the end of its row. So I'll have 2s, 2p. And then aluminum is on row 3. So it'll have 3s and then 3p. Okay. And it is the first element there, so it'll just have 1 electron in the 3p. There we go. All right. And so technically, you probably don't have to draw out, this much. I'm just doing it kind of for the sake of teaching here. But the question, they happen to ask about the 3rd ionization energy, which means you're wanting to look at, what it will cost you to remove a 3rd electron from the atom. So as long as you have enough of the orbital diagram drawn out where you can see 3 electrons in, that's really kind of, what you need to make the judgment call. So what we're going to do is we're going to go through each atom and kind of look at the effects of removing 3 electrons. And so remember that you're always going to start removing from kind of the outer shells first. So for example, we'll start removing from the 4th shell as opposed to the 3rd one. All right, so let's start here. So if we remove 3 electrons from calcium, what would happen? So there would go 1, there would go 2. Now at that point, the 4s would be empty, all right, which is a good thing. And then the 3p below would be full. So if we took off one of the electrons from that 3p orbital, that would probably not be a favorable thing because it's messing up a filled orbital. And for atoms, if you have a filled subshell, kind of all the way across, that's a stable thing, and so they don't like to mess that up. All right, so probably not a good thing for calcium to remove that electron. Now let's take a look at what happens when we do the same thing for krypton. So if we do it for krypton, we'll start in the 4p, and it would lose 1, 2, 3 electrons. So if this happened, what this would result in is a partially filled subshell. So it's not, as good as a completely filled one, but it's still not too bad. So we'll kind of put a little medium face beside it. Okay, so not quite as bad as calcium, But let's see if aluminum can do a little better. So for aluminum, we'd start by removing the 1 and the 3p. So far so good. Then the next two that would come out would be in the 3s. For aluminum, this would then create kind of 2 completely empty subshells, which is good. And it would also leave aluminum with 2 completely full subshells, which is another good thing. So for aluminum, this seems to be the most favorable. And so that's going to make his electrons easier to remove. If the electrons are easier to remove, you don't have to put in as much energy, so that ionization energy is going to be low. All right. Calcium had the most unfavorable kind of thing happen to him by removing that 3rd electron. So his ionization energy will probably be high, and krypton's will be somewhere in the middle. So calcium would have our highest ionization energy, then krypton, then finally aluminum with the lowest. And if you were asked to rank them from high to low, this would be the order, but low to high